Dear world, welcome back to the breakfast BFS Graph Traversal method. So in today's video, we'll be understanding the BFS, then we will be understanding the mathematical portions, and then we will convert the concept into codes. So let's understand to the board. So the name as the breadth-first search. So this is nothing but a tree traversal technique of graph. That you can see, this is a graph. And what is graph? It is connected when there is a node and the connection of nodes like this. If they're connected like this is called a graph. That is called a graph. And when we traverse, there are two types of traversal we can traverse. One is if we traverse only towards the depth, we call that depth first traversal. But when we traverse through the level by level, when we traverse through the level by level like this, when we traverse like this, zeroth level, then we're traversing the first level, and then we're traversing the second level, this level by level. That means when we apply that type of traversal, when we get the answer, the output like this, 0. First we traverse this level, 0th level, then the first level, that is 1 and 2, 1 and 2, and then the 3 4 5, 3 4 5 of the third level. So when we traverse by level, then we call it breadth first traversal or breadth first BFS method. So the traversal method of level by level is the BFS approach. And in today's video, we'll be understanding that how we can apply, how we can convert this concept of first traversing this level, then traversing the next level, then traversing this level. We'll be converting that into concept. So let's understand what it tells. Breadth first search is a traversal technique that explores wall nodes at the present depth before moving to the nodes at the next level. That means it explores one node at the present depth. That means whenever we are here, we'll be exploring all the nodes at the present depth of 1, this node, depth of 2, this node. So here we have traversed first 0, this node, and then 1 and 2 current depth. In the next one, we again move to the next section. Now notice we traverse 3 and 4, 3 and 4. So what we are doing, we are actually traversing all the nodes of current depth. So that is the breadth first technique. That is the technique to traverse by level by level. So let's understand, when we want to implement that type of scenarios, breadth first, we use two things. First of all, we have to implement the graph. First, what we do, we always have to implement the graph. That means we have to create this graph, and for creating that graph, we'll be using adjacency list. First, we'll be using adjacency list for what? To create the graph. To create the graph. Create the graph above that we can see. Second, what we need to do, we need to create the method. We need to create the method that how we can traverse, our program can traverse here, then our program will be traversing here. We have to build that logic, and for building that logic, we will be utilizing one thing, that is kiwi. We will be using kiwi. This is kiwi that we will be using. And another thing that we will be using, suppose we visited that zeroth element. We have visited this zeroth element. So how do you know that we have visited this zeroth element? For that, we need to track how we visit, and for that, for keeping track that which elements I have visited 0, then let's say I have visited this 1. So keep track of all the elements that I have visited. I will be using a set named visited. So this is a visited set where we'll be tracking who has been visited. So this is 0 1. So that is the thing that we'll be using. First, we'll be using adjacency list to represent the matrix. Second, we'll be using kiwi. To process the entire data structure internally. We'll be using kiwi. Third, we'll be utilizing a visited set to keep track of which nodes has been visited. You might be thinking that why we need to keep track of all the nodes that have been visited. Look, when we are here, it might be that this is connected with this element, this is connected with this element. So notice, when we are in one position, when we are in this position, just try to notice. So we will be visiting that element, then we'll be visiting that element. That means from 1 will be visited both 3 and 4. Now notice the second portion where we are in the 2. When we are in the 2, again this is connected with 4, which has been already visited here. So we'll again visit the 4, but we don't need to visit one element two times. That is one from that is one from, this is one from 3 and 4, and another from 2 to 4 and 5. So notice the element 3 and 4 is encountered twice, but we want only once, and that is why we will be using a visited array. This is, we will be using a visited to keep track that if 4 has been visited, that is if 4 has been visited, so we will not include it here. Got it? So this is the core logic. So let's understand this small concept in more details in programmatic manner. So let's move to the next page. BFS steps. So this is the algorithmic step that how we can implement. So what it tells, start at the selected node. That means the node selected. Suppose we will be solving a question. Suppose we will be solving a question. So in question we might be given a node that you have to start with node, let's say 4. That means you have to start from this node. So let's say in another question that is we have to start from the node 0. So then we have to start from the 0. That means we will be starting from any node, anything is given. We can either start from here, we can either start from here, or we can start even from here. Anything from the beginning, from any node we can start. Got it? Second, visit each unvisited neighbor node and add it to the queue. That means we have to visit all the nodes, neighbor nodes. If suppose we are starting from 0, then the neighbor of 0 is who? The neighbor of 0 is 1 and 2. The neighbor of 0 is 1 and 2. And from where do we get it? We get it from the adjacency list. Adjacency list is the list that we create to represent the matrix. So here we represent actually node, and this is the list of type integer. So if 0, look, 0 is connected with 1 and 2, so there will be 1 and 2. Let's say 1 is connected with 3 and 4, so the neighbors of 1 is 3 and 4, so 3 and 4 will be in this list. Let's say 2 is also connected with 4 and 5, so the list will contain 4, 5 and 0. 2 is also connected with 0. Here 1 is connected with the 0 also, so I have to include the 0 also, and 0 is connected. So this is the list. From this list we will be checking if the neighbor is not visited. Then we'll be doing what? We'll be adding that to queue. That means we'll be adding, if let's say this 3 is not visited, so we'll be adding this element to queue. So 3 will be coming here. Continue until the queue is empty. So we have to keep processing the nodes. We have to insert the node, then we have to again poll the node, until the queue is empty. So that is, so what we actually do in the algorithm, that is, first we actually find the algorithm. Okay, now next most recap that how algorithm internally works. First, let's say we now start processing from the 0. Let's say we are starting processing from the 0. So what we do when we start processing from the 0, we first take the node 0. So now we'll be pushing this node 0 into the queue. So 0 will come here. Let's say 0 is pushed here, so 0 will come in that position. 0 will come in that position. Got it? So when we are traversing 0, now we have to search the label. Now we'll be adding the node 0 to the visited set. This is our visited set. This is visited. So as we have visited 0, we'll be adding it to this also 0. And this is the kiwi. So next what we will be doing, we have visited the 0. Now we will be, first we will be inserting that one, and after it has been inserted, now we will be polling that one. We will be fetching that element or retrieving that element. That means 0 will emit out, and when 0 will emit out, when 0 will come to a, let's say, current node, we will be storing this 0 into a node, let's say current node. So when the current node is having the value of this 0, so now we'll be checking for this current node. Now we'll be checking for this current node 0, that if it is having neighbor or not. If it is having, so notice this 0 here. 0 is having two neighbors, 1 and 2. So simply what we will be doing, we will be pushing them back. We will be pushing them back into the kiwi. So 1 and 2 will come here. From this side, 1 and 1 will come here and 2 will come here. Got it? Now 1 and 2 has come here, so we'll be visiting the 1 and 2. We'll be adding that into the visited list that they have been visited. Now in the next step, we will again do the same thing. We will again pop from the kiwi. We'll be popping the 1, and whenever we pop the 1, we will be checking if 1 is having any neighbor. Now notice 1 is having neighbor 3, 4 and 0. The neighbors of 1 is, this is 3, 4, 0. But notice the 0 has been already visited. Here is already 0, that means 0 has been visited, but 3, 4 is not here. 3 4 is not visited. This 2 3 and 4 is not visited. 3 and 4 is not visited, that you can see. That means we can insert the 3 and 4. So simply we will be again pushing them into the queue. We will be pushing the 3 4 into the queue. So let's push the 3 4. So 3 and 4 will come here. So 1 got emitted. Now again we'll be pulling back 2. We'll be pulling back 2. Now we'll be checking for 2. That so 2 is having 450. So we'll be check if 450 is visited. So 3 and 4 has been visited. So now we check 450 to 450. So notice 4 is visited and 0 is also visited, but 5 is not visited. 5 is not visited. So we can push the 5. We can only push this 5 into the kiwi. So we'll be pushing the 5 into the kiwi. So once we have visited all the nodes, now one by one we'll be popping and fetching, and we'll be printing the elements, and that's how we traverse the BFS breadth-first algorithm. This is called, and this algorithm will provide us the correct result in this manner: 0. First we get 0, then we get 1, then we get 2, then we get 3, then we get 4 and 5. You can see the list here. So this is the list you got from here. That is the traversal, breadth by breadth, and that is the main concept. Now let's implement it with the help of programs. So whenever we implement a class like this, we'll be starting with this link, let's say. So first we'll be naming the class as graph BFS, the same name we have used here. So public class graph BFS. First we'll be creating this class file in the Java. Then to implement the graph that you are seeing in here, we have to either use adjacency list or adjacency matrix. So here we'll be using adjacency list. So let's declare the adjacency list. So private final, and we'll be using map for it. We'll be utilizing map for it. So let's use map, private final map, and we'll be using two arguments. First, that is integer, and the another argument, that is list of integers, list of integers. Okay, and let's call it the name adjacency list, and we call it adjacency list. Now after we have created the class file, we have to declare the constructor. So let's declare the constructor. Public graph BFS, and we'll be just this is non-parametric constructor, so adjacency list, that is equals to new hash map. We are implementing this map interface with respect to new hash map class. So by this we have declared the constructor class. So if you just try to notice that after this program, what is actually the architecture behind, so you will be noting like this. This 0 is represented like this internally. This 0 is like this. That is the integer part. This is the integer part. This integer part is this integer part, and the next at least of integer, this part, this is the least of integer part, least of integer part. Can you understand? And not only this node, all the nodes are like this. All the nodes have a similar architecture like this. They are defined in that manner. That means we can actually visualize all the nodes like this in that manner, because they are now we have initialized them using the map data structure. Now what to do, we will be adding the edge. Notice now the edges, the edges like this. Now we'll be adding the edges like this. We'll be writing the program to add those edges. So for that, let's write the function public void add edge. Public void add edge. And to add edge, notice we add edge like this. That means we actually need 2 points for that. So as we need 2 points, so we'll be just taking the 2 points like integer u comma integer v, integer u comma integer v, integer v. So we have taken 2 points here. Now we'll be checking if they exist in the list, this list or not. So adjacency list, adjacency list, this adjacency list dot compute if absent. So we'll be checking the first point u. We'll be checking with respect to this point also and this point also. So with respect to this first, let's say this is point u and this is point v. So we'll be checking if this u point exists. I mean if array neighborhood array exists for this u point. If not exists, so let's create x2 new array list dot add. After we create the list, we will be adding our node. So we have added this in the program. Now again adjacency list dot compute if absent. Now we are checking for the second point v. If v is, we'll be checking if v is present, and with respect to v if list is present. That means if we call v, we'll be checking if this is having this adjacency list, and if that list is not having, let's say that is not, this is v and this is not having, so then create a list for this, so that is the code line what it tells. So adjacency list dot compute if absent v comma x2 new array list, that means create a array list. After it has been created, now we'll be adding the u, add of u. So if you try to understand in terms of computer language, so computer is not having this box like this. Computer has no internal box like this. Computer is not having that type of box. Instead, computer is having that type of architecture. Computer is having that type of architecture. This is the integer part, and this is the list of integer part, and this is having the point 0, this is having the point 1. And with respect to point 1, when we added, when you just call this function, let's say this is u and this is v, when you call this function u, this one compute if absent, and if x compute, it will check if this is having that type of list, and if that is not having that type of list, then it will create. Once it has been created, now the second portion dot add of v, that means in the room of u v, that means 1 will get added. Next, after 1 has been added, in the room of 1 we add the u dot u, so 0 has been added. Once 1 and 0 both are added with them, the line is created. Then we understand that a line has been created. Computer understand our human vision, that this line is created, existed between those 2 points. That is the core understanding, and that is the add age method. So this is the entire add age method. By now we have added the age, and once we call the function for main, it will add age as per our choice, that we want. That is graph. Okay, so by now we have created this. Now we will be implementing the main method for the BFS class. So first, for that we'll be creating the function public void BFS. So let's write public void BFS, and always we'll be starting a BFS with any given node that we want. We can either start with this node, we can either start with this node, either we can start with this node. It only means that we will be provided with the start node. So public void BFS, and now we'll be provided with start node, integer start node. And now, so first what we need to do, first we always need two things while we implement the BFS system. We always need two things. First we need a queue, this queue we require, and the second we need a set, visited set. That means the things you can see here in the left side, we always require these things and these things, the queue and the visited set. This is the name, but this is the set interface. So now we'll be implementing that class. For that we'll be implementing, or we will be initializing that class. So let's create a queue where we'll be storing integer, queue of integer, and we call it queue. We'll be implementing this queue with respect to array dequeue, because array dequeue is more optimized than anything like array list, linked list. So we will be utilizing array dequeue. So that is equals to new array dequeue, that is equals to new array deque. So this is the interface class that we are array deque. So okay, by now we have created the array deque. Now we need to create the visitor set. So we'll be creating the visitor set. Kiwi, I mean not kiwi, set. This is set where we'll be storing integer. Set of integer. Set of integer visited, and now we'll be implementing this set with respect to hash set. So new hash set, new hash set, and by now we have implemented this new hash set. So this new hash set will be tracking. This will be tracking which node. Suppose we have visited this 0 node, so we'll be adding here. Suppose we have visited this from 1 node, we'll be adding here. We have visited this 2 node, we'll be adding here. We have visited this 3 node, we'll be adding here. We have visited 4, we'll be adding here. We have visited 5, we'll be adding here. So when one by one nodes are visited, we keep track with the help of this visited. With the help of this visited, we keep track that things. So we have implemented that things. Now once we have done all the things, we have created the queue. So what we have to do, whenever suppose this is our start node, let's say this is our start node, that means we are, that is our start node, that means we are provided with the value. So to initiate the program, we will directly insert this start node 0. We'll be directly inserting that start node into the array, into the queue. So first let's start by adding the node, and whenever we add any node in queue, we'll be adding that node in set also, because we have to track. So we'll be adding, now we'll be adding this queue start node. So queue dot start node, queue dot add start node. Now we are initiating the program, and similarly we'll be adding to visited dot add start node. So by now we have added both the element into the queue and stack. Now we start the BFS traversal. So we'll be simply writing a line like this: system.out.println BFS traversal, system.out.println BFS traversal. Okay. Now we will be traversing till this queue is not empty. Till this queue not equals to empty. I mean until this queue becomes empty, we will be running our for loop. We will be running our for loop till then. So we'll be checking if queue is not empty. If queue is not empty, we'll be checking that. So let's write this code line like this: queue while not of, that means until queue is not empty. So while not of queue dot is empty. So until queue is not empty, our loop will be working. That means our loop will be working. So what we'll be doing, we'll be just polling this current node. So this is the current node. That means if we have inserted this 0 as the current node, we will be polling this node back from the queue, and then only we'll be adding again two nodes, polling then adding. So first we'll be polling elements, polling, and then we'll be adding elements. So let's poll the elements with respect to current node. So integer current node, integer current node. So kiwi dot poll. Once you apply this kiwi dot poll, 0 will be popped back from here, and it will come to the our current node. Our current node will get that kiwi node. So now we have polled the element, and our current node is having the current 0 node. 0 node has been pulled out, and current node is having this value. So we'll be simply printing this current node value. System.out dot println current node. We are printing the current node plus few spaces. So we have added spaces. Now we have printed the current node. Now we'll be checking. Now we'll be checking for the neighbors of the current node. That means what we need, 0. Try to understand the 0. This is 0, and 0 is our adjacency list. So 0 is having the neighbor nodes name also in here. So neighbor nodes are 1 and 2. So now we have to insert it neighbors node. So what we need to do, we have to extract this, and we have to assign in some called neighbors list. So we have to create that type of neighbor list, and we have to retrieve the neighbor list 1 and 2 here. This is the neighbor, this is the neighbor, that list. and then only we can add. So we will be extracting or retrieving that into the list of neighbors. So let's create list of neighbors. List this is the list containing integer and which will have the neighbors. So we'll be naming it neighbors, list of integer, and it will have neighbors. So we'll be just retrieving in it with respect to the adjacency list. So adjacency list dot get will be getting with respect to the current node. That means all the we have already all the neighbors. So as we have already all the neighbors, now we'll be checking that if neighbor is not null. That means let's say we got like this and this is empty. So we have no meaning to check the empty thing. So we'll be check if neighbor is not null. That is if neighbor not equals to null. If neighbor not equals to null, then we'll be running a for each loop. Then for this is the neighbors, that is neighbors, if neighbors. So for neighbor, for we'll be calling this for integer neighbor. So for integer neighbor in neighbors, in the adjacency list of neighbors we'll be checking if, so we'll be checking that if that is not present in the visited, that means this is very, so if that is not visited, if that is present in visited, if that is present, so it will return as false. Let's say 5 is present here, so that will return false. In this case we'll be running that program, and if that is not present, that is empty, so we'll be getting true. So we'll be checking that condition if visited dot add of neighbor, dot add visited.add of neighbor, that means the element we want to add, if this element is not present, if this element that we want to add is not present, then we will get the value as true. We'll be getting the value as true. Then we'll be simply adding that value to kiwi.add neighbor, and this line will automatically handle the case to add in the visited set. And if that is this element is already present, we get it false and we don't execute the loop. So okay, now we have executed the loop. So by now we have checked all the programs and it has been executed. So all the nodes, all the elements after this program, it will run and it will automatically check all the things. So after everything has been done, now we need to print the graph from with respect to the map. So let's write the print function. For that we'll be writing the print function. So let's write the print function. Public void print graph. Public void print graph. And now we are printing the graph. So for that we'll be writing for, so now we'll be creating a variable of the entry set. So map.entry, for map.entry, and this map is having integer and list of integer, and we this is the entire class. And now we'll be initializing a variable with respect to this entry. Entry is the variable. We'll be checking with respect to that in adjacency list dot entry set, adjacency list dot entry set. Now all the entry set will be coming to that adjacency list. Now we'll be printing the value. So system.out.println, system system dot out dot println, and now we'll be printing the node and its adjacency list. So nodes, first let's print the nodes, that is nodes entry.getKey, entry.getKey. So we have gotten from the key position, and this node is connected to the adjacency list of neighbor, is connected to neighbors list plus entry.get value. Once we apply the entry.get value, it will automatically provide us all the values. So entry.get value plus entry.get value. So okay, by now This will run and all the elements will automatically get printed out. This is just one line of code. We'll be observing the VS code, and after that we'll be running the main function. So let's run the main function. So now we'll be running the main function. Public static void main. Public static void main string args. String args. First we need to create our object of this class graph BFS. So graph BFS graph, that is equals to new graph BFS. So once this is new graph object has been created, now what we need to do, we have to add all the edges. So we'll be adding edges one by one. So let's say we'll be adding edge like this, graph dot add edge, graph dot add edge, and let's say we are adding 0 comma 1. Once we run the program graph dot add edge 0 comma 1, then the 0 and 1 will get connected. 0 and 1 will get connected. Now we'll be running the program graph dot add edge. We'll be adding the program graph dot add edge 0 comma 2, and 0 comma 2 will get connected. Now let's say we run the program graph dot add edge, graph dot add edge 1 comma 3. So by now 1 comma 3 will get connected. Now again we run graph dot add edge, graph dot add edge, and now we'll, let's say 2 comma 4. So it will add the 2 comma 4. This one will get connected. Now let's say we are just running graph dot add edge, graph dot add edge, graph dot add edge, and this is 2 comma 5, or we can call 4 comma 5. So now the 4 comma 5 will get connected like this. So that is a graph. We can even connect the 1 and 5 like this, graph dot add edge, graph dot add edge 1 comma 5. So once we have done this graph dot add edge 1 comma 5, 1 and 5 will get added like this. 1 and 5 will be get added like this. Now we have to start the BFS process. We have to start the graph BFS process. So before that we should print this graph. So for that we'll be calling simply the method. We'll be calling simply graph dot print graph. Graph dot, the name of the function is print graph. So graph dot print graph. Graph dot print graph. Graph dot print graph. And once we call this function entire graph, this graph will get printed out. That graph will get printed out. So now we need to start the BFS process. So we can start with any node. So let's say we want to start this 2 node. So we'll be running like this, graph dot bfs, graph dot bfs, and once we pass 2 here, 2 becomes a start node. This 2 becomes the start node for the program to be started. And now if we just run this program, we will get entire BFS to be executed line by line. We will be getting the entire program to be executed line by line, level by level. And as it traverses according to the level by level, we call it breadth first search. So let's watch the program in the VS Code. And for that, wait a while. Let me set up the VS Code. Just let me open. Okay, first I need to open the VS Code. Okay. So now we'll be moving towards the VS Code and we'll be writing the entire program. So now we are in the VS Code, and now let's create a file name BFS YT class. So there is already a file YT, and there is already YT That means we have previously completed all the things of YT Now YT BFS. So let's create a file mkdir YT BFS command YT BFS. Okay, by now we have created the YT BFS. So now we'll be creating the file graph BFS. So let's create the file graph BFS. Code graph bfs.java. Okay, so this is the graph BFS, public class graph BFS. So first what we need to do, we have to clear the adjacency list. So private. So first we'll be creating the adjacency list. So we'll be writing like this, private final, and we will be implementing with respect to map, private final map integer, list of integer, and let's call it adjacency list. Now we'll be declaring the constructor public graph BFS, and now like this, adjacency list that is equals to new hash map, because we are implementing with respect to new hash map. So this is, we simply call it new hash map. So after that we will be adding the function to add age. So let's write the function of add age, public void add age integer u comma integer v, adjacency list dot compute if absent, adjacency list dot compute if absent u comma x, if u is absent so then create new array list, and then we'll be adding v with that, add the v point to that list, adjacency list dot compute if absent v comma x to new array list, and then if v is present then add u. So okay, we have written the void addage function, we have created the graph by now. So now we'll be implementing the BFS function, optimized BFS. So let's write for that. So first we need to create the QE. So we'll be writing the function like this, public void BFS, public void BFS, and we always pass the start node here, integer start node. So now we'll be creating the QE. So let's call the QE, and inside this QE will be storing integer QE, and we'll be implementing with respect to array DQ, new array DQ. Okay, so after QE we'll be utilizing a set storing integer name visited to track the visited nodes, that is equals to new, and we'll be using hash set for here, hash set. Okay, now we'll be adding the start node in the QE dot add start node. Now we'll be adding in the visited dot add start node. So now we have added all those elements. Now we'll be actually starting the traversal here, system.out.println BFS traversal. Okay, now we are traversing through the BFS traversal. So first we'll be checking while until the queue is not empty, not of queue dot is empty. Until the queue is not empty, we'll be keeping polling all elements. So integer current node, that is equals to queue dot poll. So that is the first processed, all processed. First we add, then we poll, then it is called processed. So this is the processed element. We print this element, system.out.print, and after we print current node plus few specials. Okay, we have added few specials here. Let's add this. That means we have visited in this arrow manner. So now we have visited this element queue.poll. So now we need to get the adjacency list, and for that we will be retrieving the adjacency list. So we have to declare list of integer neighbors. The adjacency list is of nothing but neighbors that is equals to we need to get with respect to that current node. So for that we will be simply writing that adjacency list dot get with respect to that current node. So we'll be getting the adjacency list, that is connected we might be getting. So now if neighbors is not null, then we'll be processing the further checks. Neighbors, sometime the list might be entirely null, then we no need to check. So if the neighbors is not null, then we'll be running, that means there are neighbors. So for integer each neighbor, in neighbors we'll be checking if that neighbor is not visited. That means if, then we'll be adding into visited, but we'll be checking in one statement, that if visited dot add, of neighbor. So that means it will add the neighbor if that is not present, and if that is present then it will return the false. So this is that visited.add of neighbor. So add the neighbor into the visited list if that is not present, and then run the program. And if it is present, it will return false and it will not execute the program. Then we will be adding it to kiwi also, kiwi.add of neighbor. So this is very much optimized method. So now we have added the kiwi and we have processed the BFS. Once we have processed the BFS, now we need to print the graph. So public void print graph, public void print graph, and for that print graph simply we'll be just implementing a for loop with respect to map.entry. For map.entry, for map.entry, for map.entry entry integer with respect to list of integer, and we call this as entry in the adjacency list dot entry set. And now let's print system dot out dot print dot println. Now we will be printing all the nodes one by one. So node and plus entry dot get key. So this is actually added with the get key position. Node is connected to neighbors plus entry dot get value. So it will return as a get value all the elements. Now we need to write the driver program. Public static void main string args. So first we need to create a graph BFS class, graph BFS, and then we have to create the object BFS that is equals to new graph BFS dot add, and with this BFS we have to add, we call it BFS, and now we'll be adding all the edges. So let's say we want to add 0 and 1. So 0 and 1 is added. BFS dot add. Now we want to add the 0 and 2. So 1, 0 and 2. Then we want to add the 1 and 3. So BFS dot add 1, 1, 3. BFS dot add 1, comma 4. And then BFS dot add. After that we'll be adding 2, comma 5. BFS dot add, we'll be adding 2, comma 6. So all those elements are added. Now we want to print the graph. BFS dot print graph will print the graph. Now we want to start the traversal through BFS graph. Will be running BFS dot, the method name is BFS with respect to the start node 0, let's say. Now the program should run, but I'm getting few errors. And let's see, cannot infer type argument for hash set. There should not be any error. New hash set integer visited new hash set. Cannot infer type arguments for array set integer visited graph BFS. Oh, it will be the constructor public void graph BFS, and they are providing some error. And the last line BFS dot add, BFS dot add. Oh sorry, this will be add age method. There is nothing like add. This is add age. Add age. So we are adding the age, and now there is new hash map. So hash map cannot be, actually we miss the type here, that the type is same. So now there is still few error. New hash map. Okay, new hash set. So I think hash set is there already. Set integer new hash set. Let's run the program and see what happens. I'm still getting error. It might provide a compile time. This class implements the set. So if you run java compile minus d dot graph bfs dot java and cannot find symbol. So I think here we haven't imported the set, that's why we got the error. Import java.util. I thought that it will get automatically. So now see, all problem has removed. Sometimes I think that the VS code automatically imports, but it doesn't import actually. So okay, now you can see the program. This is the class graph VFS. So let's compile first. Java compile and Java graph VFS. And as you can see that 0 is connected to number 1 2 2 1 2 0 3 4 0 5 6 as I saw you, and these are connected to 1 1, and the traversal is like this 0 1 2 3 4 5 6, and that is the way the elements are traversed. So first we have created the class graph bfs, then we have created the private, this is the access type, this is the final, it cannot be changed, and the data structure we have utilized is of map, which is having the type integer and list of integer, and the name is adjoint list. Then this is public graph bfs, we have created the constructor and initialized the new hash map. Look, we have clearly mentioned the type here, that means the same type is also provided from here while creation. Now we are adding the addage with respect to 2.7v by checking, that is adjoint list dot compute if absent u comma x. That means if u is not present, then this type of annotation x with respect to x to new arrow list will create a new array list for that u, and it will add v into that list. Adjoint list dot compute if absent v comma x to new array list dot add of v. Now we are initializing the program of public void bfs. So first we create a QE. At the start of the BFS method, we actually create a QE with respect to the most optimized version of data structure array_dq. Then we run the set visited set with respect to new hash set, and then we add the start node in both the QE and the visited set. So after we have added in the QE, the next task is we have to pull from the QE. So we start pulling method and we write BFS traversal. So first we pull until the queue is empty, we keep pulling elements and we keep inserting. So insertion then pull. So it is the current node that is equals to QE.pull. So we have pulled the element of current node. Then again we print the current node that we have pulled. So that is the first printing element, and this is arrow. Then we create a list of integer neighbors to fetch the neighbors from the adjacency list. So we fetch the corresponding neighbor adjacency list dot get of current node. With respect to the current node, we fetch the elements. Then we check if neighbors, that means if this list of integer is not null, that means if it is having data, then for those data which we start traversing all the nodes with one by one. So visited dot add of neighbor, that means if the neighbor is not visited, now if not visited, then it's automatically added via this line visited dot add of neighbor, and then we add it into the queue dot add, and this process, this traversal method, which goes like this: one time insertion then pull, automatically handles the entire bfs case. Then this is public void print graph for map.entry integer comma list of integer. So with respect to this data entire declared data type map.entry, we create our entry that is for each, and then we search in the adjacency list.entry set. It provides the entire entry set, and then system.out.println node.entry.get key. That means we fetch the get key from this item entry. This is get key and value. So we fetch the entry.get key keys and the values, that means adjacency list. This first one is called key and the second one is called value. So entry.get value, and then we declare the public static void main. We create an object and we add the nodes. Then we print the graph, and then we start from the start node bfs.bfs, and after all this we get the output like this. So okay, it's all about. I wish you understood a lot of things about this.